if you let t go to infinity and price t does not grow faster than the discount rate, you could basically write valuation as, this is just a fancy notation, not 0, 1. That notation means for each value of t, calculate the present value of the expected dividend payment and add them up. The fact that I'm doing this until infinity doesn't change anything. That's just a fancy notation for doing this, and end it with a dot, dot, dot instead of whole thing. But the way we interpret that is value of the stock is equal to the present value of all expected future dividends. That's all that means. Theoretically, there is nothing wrong with this approach. If God, Buddha, or whoever you find as a deity told you what those dividend payments were going to be, you can make that calculation, no problem. But we're rarely that lucky. In real life, in order to use this model, you actually have to make predictions about those. There are a lot of problems making this model operational. The first problem is when you look at the markets, do you see any equity analyst that makes predictions about what the dividends are going to be 5 years from now? No. They may make predictions about earnings or cash flows, free cash flows, but nobody ever makes predictions about what dividends are going to be. Why? Because, first of all, dividends are completely discretionary. The company may decide we'll pay nothing for the next 5 years, then we'll pay a lot. Or we'll pay a lot for the next 5 years, then we'll stop paying. There is no way to predict what's going to happen with that. I mean, there are market forces that kind of limits behavior of the boards. If a company is already paying dividends, if they suddenly cut their dividends in half, market is going to punish them big time. Because that typically is a sign that there is trouble with the company that we were not aware of. They had to cut the dividend just to generate more internal resources. So any company that cuts their dividend unexpected to the market is going to be punished big time in the market. Their stock is going to tank. So if you're already paying dividends, chances that you're going to cut those dividends are relatively small unless there is something really major going on. I mean, think about the COVID crisis, right? If Coke decided to cut their dividends during COVID crisis, nobody would have blamed them, or 2008 crisis, for that matter. But right now, Coke is paying what's around $1.50 a share in dividends. If they said tomorrow, okay, starting next year, we're going to pay only 50 cents, you probably would see Coke stock tank by about at least 30-40%. But some companies never have paid any dividends. The most famous example right now is Google. Google was established in 97, 98 as a firm when the Google guys, Sergey and Larry, I think, they were PhD students at Stanford. Their dissertations were about the search algorithms anyway, so they established Google. They went public in 2004. Over the last 20 years, even after they went public, they have not paid a single dime of dividend or single cent of dividend. They just chose not to, which means this model is completely useless for the purposes of valuing Google. So unless company has a stable history of paying dividends and they're not doing big surprises in any given year, this model is not that useful. It's a nice little teaching tool. Some of the other evaluation methods we use in upper level classes, such as residual income model or discounted cash flow model, they use similar techniques. So in that sense, it's useful, but I would not recommend you to use model to make any trading decisions whatsoever. You can still ask certain useful questions, especially about firms that have a consistent history of paying dividends. But this model should not ever be your sole source of valuation. We already talked a little bit about valuation using multiples, and we're going to do more of that next week. But for now, we have just this one. In addition to dividend estimates not being readily available from outside and reliable sources, even if there were, this model relies on dividend estimates for very long periods of time. If Coke has been known to have paid dividends and to have increased those dividends every single year for the last 60 plus years. As far as dividends are concerned, there is nothing more stable than Coke. Similarly, Pepsi is like that too. If you went to a Coke executive and asked him or her, what do you think dividends are going to be in 2045? They would kick you out of the room, okay? Because they have no idea. That shouldn't be even a question. They may tell you the next 2-3 years. They may tell you about what is their overall strategy would be, but they're not going to give you a number. Even if they did, you should not trust the estimates of the 20-year ahead dividends as much as you would trust estimate of dividends next year or year from two. That's kind of one of the laws of nature. If you know anything about physics, it's called the second law of thermodynamics. It's probably even more important than Newton's laws of motion. There are 3 laws of thermodynamics. Second law says entropy always increases. Entropy is a fancy word for disorder or uncertainty. Take any local system, over time, uncertainty or disorder of that system always increases. In fact, if second law of thermodynamics is violated, then you know that traveling to past in time is allowed. That's one of the implications if there is such a violation. Around black holes, sometimes it happens. So the model uses inputs that are increasingly unreliable. So we kind of need to make it operational by making simplifications. Now, in economics and finance, but even in physical sciences, models are useful only in the context they're useful. Example, you guys heard about Newton's laws of motion, right? Newton has this equation. Using that equation, you can predict where Jupiter is going to be 200 years from now. It's not that complicated. Even if you can't do it by hand, computers can solve that differential equation for you, even in the presence of Saturn and stuff. Just like we have templates, you have templates for the solution of those equations as well. In the old days, they used to do those by hand. Actually, they had what they called human calculators. these Rain Man kind of people, the idiot savants. Euler, for example, had two of these guys employed. This is late 1700s. Anytime he needed a calculation, he wrote the numbers down. These guys can multiply 7-digit numbers in their head and divide them, and they would give him the result. He would calculate the tables and so on and so forth. These days, we have these computers to do the calculations for us. So until the end of 19th century, beginning of 20th century, nobody even dared to doubt Newton. Okay, he was the giant. I mean, pound for pound, he was probably the smartest guy ever lived, even smarter than Einstein.